Everything in the world is made up of submicroscopic particles called atoms. These pups are made up of atoms of carbon, hydrogen, oxygen, nitrogen, and sulfur, among other things. This is an oxygen atom, and I know it's an oxygen atom because it's got 8 protons in the nucleus and 8 electrons outside of the nucleus. Almost 21% of our atmosphere is oxygen, and it's necessary for life on this planet. We can't live without oxygen. Oxygen is an element. It's made up of one type of atom. So all of the atoms that make up oxygen are going to look pretty much the same. And here's the periodic table of elements. And there's oxygen. We'll talk more about how the periodic table is laid out later on. Now, elements are pure substances that can't be broken down into simpler, stable substances, but they can be combined with other elements to form compounds. So we can take an oxygen atom and bond a couple of hydrogen atoms to it, and they're going to form a compound, which we know is H2O, or water. Now, it is possible to break a compound down into its respective elements. In this instance, I can take water and I can break it back down into oxygen gas and hydrogen gas. But it takes a lot of effort to do that, since these atoms are now chemically bonded together to form a compound. Now, just like elements are pure substances, compounds are also pure substances. Every sample is going to have the exact same composition and properties. Now, we can take different compounds like water and sodium chloride and combine them to form mixtures. Since we know sodium chloride is going to dissolve in the water, my mixture is going to look the same or uniform all the way through in its composition. That means that we have formed a homogeneous mixture. Another name for a homogeneous mixture is a solution. Here's another example of taking two different compounds and creating a mixture. Again, we'll start with our water, and to it we'll add some sand or silicon dioxide. We can see some of the liquidy water part, and we can see that some of the parts of the sand have dissolved, and we can also see that there are some solid parts in that solution. So this is an instance where our solution does not look uniform all the way through. And when you can see the different phases, the solid and the liquid parts, or gas, if that happens to be the case, then we would call that a heterogeneous mixture. Now, I mentioned earlier that elements and compounds are both considered to be pure substances. If you take a sample of any pure substance, it's going to have the exact same composition and properties. And so we'll talk for a minute about properties. Physical properties are characteristics that we can observe or measure without changing the substance, like melting point or boiling point. The process of water boiling is a physical change. We're going from a liquid to a gas, but the compound is still H2O, water. It's just changed states. So that would be considered a physical change. Just like freezing or melting is a physical change, we're still looking at H2O. But the temperature at which a substance would freeze or melt or boil is a physical property. Chemical properties look at how a substance reacts and changes into different substances. An example of this would be gasoline, which is flammable. Flammability would be a chemical property of gasoline. The burning itself, or the process of combustion, would be considered a chemical change. In a chemical change, new products are being formed. In a combustion reaction, the products are going to be carbon dioxide and water and heat and light. Here's the chemical equation for the combustion of methane, a hydrocarbon, which requires oxygen in order to burn and forms carbon dioxide and water as the products. Now, in a chemical equation, the arrow means yields or produces, And the reactants are the starting substances in a chemical reaction, and the stuff that's formed is called product. This is chemistry, and we'll be looking at elements a lot. Here they are in the periodic table. We'll be delving into the way it's set up a bit later, but for now you should know that these columns are called groups, and these rows going across are called periods. Most of the elements on the periodic table are metals. And some properties of metals include metals are good conductors of heat and electricity. They're also ductile, which means they can be drawn into wire, and malleable, which means metals are pretty easily hammered into different shapes. Metals can vary somewhat in their properties. Some metals are fairly soft and can be cut with a knife. Others are more brittle, and mercury is a liquid at room temperature. Over here on the right side of the periodic table, we have our nonmetals. Many of them are gases: nitrogen, oxygen, fluorine, chlorine are examples of gases. Bromine exists as a liquid at room temperature. And then we have a few nonmetals that are solids, like carbon, phosphorus, silicon, iodine. And though they're solid, they're fairly brittle, and they are poor conductors. And in between the metals and the nonmetals, we have the metalloids. They have some metallic as well as non-metallic characteristics, and some of them are used in computers as they are semiconductors. And finally, we have the noble gases. This group of gases is known for being very stable and very unlikely to react.